Good afternoon, everyone. I'm Frank Cavateo. I'm the manager for TSMO Planning and Funding in the Highway Safety Traffic Operations Division. I'm going to talk to you today about the TSMO maps that we've developed for the existing One Map system. TSMO is Transportation System Management and Operations. It's a set of integrated strategies used to optimize operational performance of existing infrastructure without adding capacity. PennDOT has developed a series of documents related to TSMO policy and implementation, and they can be found on the PennDOT TSMO website. They include the strategic framework, which makes the case as why we should be using TSMO, the program plan, which outlines the needs, strategies, and actions for advancing the program, and the TSMO guidebooks, which are a series of different publications relating to the planning, operations, construction, and design of TSMO. The FHWA recognizes 6 major sources of congestion as shown in the pie chart. They include physical bottlenecks, inclement weather, and special events. PennDOT's goals for traffic operations are to address those sources of congestion by mitigating recurring congestion, maintaining mobility during planned events, and minimizing the impact of unplanned events. PennDOT One Map serves as the GIS visualization portal and provides an interface for showing sets of map data which can be exported and queried for attribute data. This application gives users the ability to query various data sets of GIS data and visualize them on a map and share between users. Users are able to filter layers, theme layers, intersect layers, view data tables, print maps to PDF, and import outside data to temporary layers. One Map brings in various data sources from across the department into one location. Sources include RMS, the Roadway Management System, BMS, Bridge Management System, and TSAMS, which is the Traffic Signal Asset Management System. And this also includes a list of all the ITS devices that we have in inventory currently. 3 system maps were created to align with the department's goals for traffic operations. A map focused on mitigating recurring congestion, another for planned events, and finally another for unplanned events. This is a screenshot of one of the maps for recurring congestion. What you see here are different layers, including an INREX layer showing the bottleneck rankings, and these were calculated using probe speed data. There's a layer for roadway tiering, and that was calculated with ADT and truck percentages. Another layer with TomTom travel time ratio, that was also calculated using probe speed data. And then there's a layer for the V2C ratio, and also for the ITS assets in traffic signals. This is a screenshot of the planned events for non-recurring congestion, specifically work zones and special events. The tip layer here shows different stages from development, active, future, and completed projects. Also another layer for the RCRS roadwork and special events. And of course, we have a layer showing the ITS assets. Our third screenshot here is for unplanned events of non-recurring congestion related to incidents and inclement weather. One of the layers shown here is for safety improvement locations, like where guide rail and rumble strips would be applied. We have crash clusters for rear end, snow and ice related incidents, curved roads, and heavy trucks. We also have RCRS incidents. We have locations showing where RWIS, the Road Weather Information Systems, are located, and of course the ITS assets. Shown in a previous slide are the ROPs. These are the regional operations plans. We have a ROP for each of the RTMC regions, starting in the west. The central region was our pilot program back in 2018. In 2020, we had just completed the eastern region, and right now we're in works with DVRPC in District 6 for the ROP on the southeast region. The ROPs are used to prioritize and fund TSMO capital projects as part of the TIP. This is basically where they're putting together a list of all the projects they want to do, and this is how we're coordinating the ROPs to put them on one map so we can see them graphically. Utilizing the TSMO layers in one map, the stakeholders were then tasked to identify the congestion, classify the congestion, and then find mitigating measures used to apply targeted strategies for each of the congestion areas. It's interesting to point out that when COVID hit, we had already completed the first 2 regions in the west and central, and we were in the process of doing the eastern region. And about 90% of those meetings had to be done virtually, and our participation stayed very high even with the virtual meetings. From the maps in One Map, you could determine the causes of congestion for an area and use that information to decide which strategy is applicable using the TSMO solution matrix shown here. This matrix and more details for each strategy can be found in Pub 851 TSMO Guidebook Part 1. The goal of the second round of stakeholder meetings was to look at the identified issues from the first round and to use the solution matrix to produce appropriate projects to address those issues. At the third stakeholder meeting, a list of projects was created and prioritized based on the discussions from the previous two stakeholder meetings. Here's an example of a project in a central region route. This is a project for an integrated corridor management through the central Susquehanna Valley Thruway. You can see on the map that there are congestion issues from the high travel time ratios and NREX bottleneck data and its proximity to a heavily signalized corridor. From that data, a project was created for the route that addresses the traffic signal corridor with controller upgrades and command control functionality, as well as CCTV cameras for situational awareness. Some of the future enhancements we're looking to in regards to new layers include performance measures. Specifically, we're looking to see what we can identify in terms of travel time reliability. And since the TSMO One Map layer was specifically designed with our planning partners in mind, trying to see also what we can do in terms of multimodal efforts, start looking at park ride capacity or maybe even ridership on public transportation. Thank you for your interest in TSMO One Map. If you have any questions, I'll do what I can to answer them for you. Thank you.
Good afternoon. My name is Jeff Roker. I'm a Senior Traffic Control Specialist with the Department of Transportation. And today I'm going to present on our Highway Safety Network screening locations, as well as the Pennsylvania Crash Information Tool. For many years, state DOTs used historical crash data to establish high crash locations and site selection for safety projects. However, using only historical crashes becomes less relevant in estimating the future safety performance, especially when traffic conditions change significantly or we implement an engineering project at that particular location. Historical data also has a wide variability in crash frequency and severity and is isolated to just that specific location. We can improve safety assessments and screenings by using the Highway Safety Manual. So last year at this event, I presented on our first round of HSM network screening, which were finalized back in 2017 and included intersections and segments on conventional roadways. Earlier this year, we completed our second network screening based on more current crash data. A big addition for the second round was the addition of freeways, speed change lanes, ramp segments, and ramp terminal facilities. Here's a breakdown of the locations. We have over 4,000 segments and 2,000 intersections on rural two-lane roads. 149 segments and 141 intersections on rural multi-lane highways, 3,500 segments and 5,600 intersections on urban and suburban roads, over 4,000 segments on freeways, and over 8,000 ramp facilities, including ramps, speed change lanes, and ramp intersections. The terminal where the actual ramp meets the intersection itself. To establish those locations, we first analyzed the existing sites from our first round of network screening on conventional roads. Then we performed a full Highway Safety Manual Part C analysis and separate analysis for the Roosevelt Boulevard in Philadelphia, which is a very unique 12-lane divided highway, the only such roadway in our entire state. Then we performed a determination of excess cost and more in-depth study on the top segment and intersection in each county. We just recently finalized a mapping application for the sites. A similar analysis was done for the freeways, except that we did not have existing sites to start with, and we used safety performance functions under Part B of the Highway Safety Manual. Here's a screenshot of the maps. The locations with the highest excess cost are displayed in red, representing the most severe safety needs, followed by orange, yellow, and green. We have these maps available in PennShare, and soon they will also be ready in both our CDART and PCIT crash systems. Speaking of PCIT, this will be my other presentation topic. PCIT is our Pennsylvania Crash Information Tool. This is a public website available to everyone for viewing our crash statistics over the last 20 years. We do have special level access for key personnel to implement enforcement, engineering, and education programs. These personnel include our MPO RPOs, municipalities, state and local police, engineering firms, and other contractors, our highway safety LELs, and community traffic safety projects. The custom query tool is a 5-step process, starting with the analysis type, if the user wants the data based on crashes, persons, or vehicles. Then selecting the date range, followed by specific crash types, how they want the data to be displayed, and finally the location of the crashes. In addition to choosing a location by a specific municipality, county, district, or the entire state, users can also go right to a map and manually choose which location they want to query. You can do this by choosing a specific point or intersection and select the buffer distance from that point. You can draw a line on the map or along a specific route and query all of the crashes within that line. You can draw a uniform circle and select the square unit in feet, miles, meters, or kilometers. You can choose a polygon or rectangle on the map. Or you can choose by region, including each of our 11 engineering districts, 67 counties, and over 2,000 boroughs and townships across the Commonwealth. And then one last slide here, we also have heat maps to choose from to view the density of crashes in a specific area. Once you bring up your heat map, you can click on a specific crash and more layer information will display, including the county, route, segment, and offset of the crash, the latitude, longitude, the year of the crash, the month, the collision type, illumination, road conditions at the time of the crash, and some other information. And that concludes my presentation for today. I just wanted to thank everyone for attending our session and look forward to answering any questions. Thanks again.
Hello, my name is Kyle Snyder. I am a planner at the Tri-County Regional Planning Commission located here in Harrisburg. Tri-County Regional Planning Commission works on regional land use planning as well as provides the staff for the Harrisburg Area Transportation Study, which is the federal metropolitan planning organization for Harrisburg covering Cumberland, Dauphin, and Perry counties. Today, I'm going to be discussing some of the projects that we are working on implementing at Tri-County related to our congestion management process and transportation safety planning. First up, I'll be talking about our congestion management process. The congestion management process, or CMP, is a federally required planning process for MPOs with a metropolitan population greater than 200,000 people. MPOs that meet this threshold are also known as Transportation Management Areas, or TMAs. The purpose of the CMP is to analyze system performance as well as alternate strategies for managing and reducing congestion within a given TMA. CMPs typically require analysis of a 5-year sample of travel data, which can come from a number of sources. This analysis and the derived calculations are used as the basis to program congestion reduction projects within that TMA for the next 5 years or until there is a plan update. The benefit to these large data samples is that there is a significant amount of information within them, but they are a static data set and they do not represent real-time conditions. With that being said, we wanted to rethink our approach to the congestion management process. We are working on integrating more real-time data sources into the mix to provide a more up-to-date look at roadway conditions. After talking with other agencies, we decided to become a Ways for Cities partner, which allows us to receive a data feed of alerts and traffic jam information coming from drivers on the roadways in real time. We also received access to PennDOT's 511 Events API this past August. The Ways data is crowdsourced information, and the 511 data also provides updates directly from PennDOT. We used a Python script to automate the access to this data from the APIs and then upload it into a SQL database. This allows us to store the data and use it for reporting or other analyses we'd like to perform later on. Through these data sources, we are getting access to data points like motor vehicle accidents, traffic jams, road closures, inclement weather, and roadway hazards. Ways and other crowdsourced data has been successfully used by other MPOs and agencies to enhance their planning capabilities and operations programs. Louisville, Kentucky was one of the first Ways partners and has successfully used Ways data for corridor analyses and to measure the effectiveness of signal retimings along given corridors. The Pennsylvania Turnpike Commission uses Ways data for real-time analytics and for dispatching of safety units. PennDOT also uses Ways data as part of their TSMO reporting and in their congestion pie chart analysis used for roadway performance. Our goal for this data is to use it as a way to monitor real-time road conditions within our region. This information can also be used to create reports and documents for our MPO boards and stakeholders regarding roadway safety and performance. We can also use this data to work with the municipalities in our region to optimize signalized corridors and intersections. Since the data is being fed into SQL databases with spatial attributes, we can also access it through our Geographic Information Systems, or GIS, and overlay it with the other datasets that we have to better inform our planning decisions in the future. Next up, I'll be talking about some of the progress we're making on updating our transportation safety planning processes. One of the primary tools used for safety analysis in Pennsylvania is the network screening tool created by PennDOT. This tool is based on the AASHTO Highway Safety Manual method. This process is used to analyze road segments across the entire Commonwealth. It works by applying certain formulas to calculate an expected crash rate for each segment based on their attributes. From there, the observed or actual number of crashes are compared to the number of expected crashes in order to get an excess value. This excess value is the driving number in roadway prioritization. This network screening approach is one of the main processes for HSIP and safety prioritization. This is an extremely technical process that requires an extensive amount of data and time to come up with all of the values. The network screening process is updated approximately every 3 to 5 years by PennDOT. Here at Tri-County, we're developing what we call a network screening tool light. We are developing this approach with the help of a consultant as a supplement to the official network screening tool created by PennDOT. It's primarily a GIS and Python-based exercise to perform the Highway Safety Manual calculations based on PennDOT's Roadway Management System, or RMS, data. The key difference is that there is some degree of error in our approach because certain variables are not found in the RMS datasets, or they're left blank, or averages are applied instead. This approach is intended to be a more accessible way for MPOs and other entities to prioritize roadways for safety enhancements. A key benefit to this is that it can be rerun as often as the PennDOT RMS data is updated. Our network screening tool Lite specifically addresses 4 things. The first part is a state roads analysis, which is based on the Highway Safety Manual formulas. The second part is a local roads analysis, which is based on the sliding window methodology found in the Highway Safety Manual. This is based on the frequency and severity of crashes along the local road network. The third part is a bicycle and pedestrian analysis, which is GIS-based and explores the various spatial risk factors related to bicycle and pedestrian crashes. Finally, there's a toolkit of low-cost countermeasures for overrepresented crash types within the Tri-County region. While these efforts are still in progress, we have learned a few key lessons along the way. First is that transportation planning and programming, based solely on static data sets, can easily be made obsolete by global pandemics. A substantial change in traffic patterns related to the COVID-19 pandemic served as the catalyst for us wanting to integrate more real-time data into our congestion management process. Secondly, there's a lot of data available for planning purposes nowadays. What we learned is that not all data sets are going to be of equal value to your end goal. This can be because of low market penetration of certain technologies, lack of ITS infrastructure, or due to a lack of broadband. Certain datasets are also extremely expensive and may be cost prohibitive to your organization. Setting up new processes takes a long time. It takes a long time to outline and implement your process. In our case, we had to develop the scripts for data ingestion, as well as work on developing an implementation for this new safety analysis. Another key is the time it takes to set up servers or web services. Since we are storing our data on a local SQL server, there was additional coordination required with the county IT department to get a server created for this purpose. There's also a time factor pertaining to understanding the data that you need for your analyses and getting them into the right format. The final takeaway is that feedback and other agencies' experience is a gift. Being able to read the case studies of organizational successes using real-time data or understanding the process they used helps to provide beneficial insight into the work. That's all the information I have prepared for you today. I'd be happy to answer any questions you may have. If you can't think of anything, that's okay. My contact information is up on the screen. If you have any questions down the road, please feel free to drop me a line. I'd like to thank you very much for your time and attention today. Thank you.
This presentation will be about PennDOT's new video sharing tool, MView. In this presentation, we will discuss the plans and goals for MView from PennDOT, some background information on MView, and an instructional walkthrough on how to use the MView site as an operator. Currently, PennDOT has over 1,000 cameras available on the MView platform. This number will continue to grow to expand situational and operational awareness on our roadways. We look to expand access to our TIM partners, especially PSP, who we will start a pilot with here in the near future. With MView platform, improved situational awareness for public TIM partners becomes a big factor, especially neighboring states who have access to the MView platform and have a one-stop shop for all states' cameras who are part of the MView platform. And as we look to grow the MView platform, we look to gain more video access from partners, especially cities and municipalities, sport and entertainment venues, and first responders. MView is a secure web-based video sharing portal for first responders and public safety personnel to view live regional video footage, providing better situational awareness from most anywhere, including desktops, laptops, tablets, and smartphones. Maryland Coordination and Analysis Center, in conjunction with the Department of Homeland Security, created this platform. Currently, over 15,000 cameras from over 200 agencies who have agreed to the CCT ConOps share their cameras today. Maryland, Virginia, District of Columbia, Pennsylvania, Delaware, Maryland Stadium Authority, Maryland State Police, Baltimore City, U.S. Park Police and National Park Service, and Johns Hopkins University and health facilities currently share their cameras on the MView platform. Now each of these users are only allowed to see the video that they have been authorized to view. When you make it to the MView website, this is the login page that will appear. To log in, you will simply use the username and password that you provided when you submitted your request forms. Once you are logged into the MView platform, it will bring you to the MView Interactive Map, which is seen on your page now. All of the cameras that you have been granted access to through your user request access form will be shown on this interactive map. As you can see, the tabs have been numbered on this page so that we can discuss in further detail each one of these tabs throughout the presentation. We will start on the interactive map by selecting a camera. As you can see here, I selected a camera in the Pittsburgh region. Once this camera is selected, a small box will appear in the top left-hand corner of the interactive map. It will tell you the organization, the region, the coordinates of the camera, and the level of access needed to view this camera. On the main interactive map page, you are able to view 4 cameras at one time. To do this, you simply click on the camera. In the box that appears in the top left-hand corner of the page, you push play video. These videos will populate at the bottom of your screen as seen on your page now. To select a new camera, you simply click on the camera, push play video, and it will replace the oldest feed that you had on the bottom of the page. When you select the Wall View tab on the left side of your screen, all the organizations that you were granted access to view cameras will appear in the drop-down menu like so. In this case, I selected PA PennDOT, all markers, and all of PennDOT's districts appear that have cameras available. To view the cameras in a certain district, you will just click on the district and select the cameras that you want to play. In this example, I clicked on District 5 cameras to view. Now in the wall view, you are able to view up to 18 cameras at one time and selected layouts that appear in the top right-hand corner of the page. Continuing with the example from District 5, I went ahead and selected 13 cameras. Now the layouts are set to auto, so it laid out the cameras in a 13-panel platform that is seen on your screen now. If you chose more cameras or less cameras, it will affect the way that they appear on your screen. When you click on the Incidents tab on the left-hand side of the screen, all the incidents that are currently on the map will appear. When you select the red diamond that is an incident on the map, it will populate the 4 closest cameras to that incident as seen on your screen. Also, a box will appear where a description of the incident is given, time received is given, and the coordinates of the incident are given. Although PennDOT's incidents are currently not on the map, they will be in the near future. When you click on the Alerts tab on the left-hand side of your screen, although no alerts were currently present, this will act just as the ticker does on the 501pa.com page. Things such as vehicle restrictions, speed restrictions, major incidents, roadway closures, amber, or even MEEP alerts can be found here. In the Profile tab on the left-hand side of the page, you will find the information you provided on your user request access form to MView. Here you will find your first and last name, your username, your organization, and your email. Here you can also change your password. Also, it will show you the last login that you attempted on the MView platform. In the Help tab on the left-hand side of your screen, an operator's manual can be found here. This will help any user navigate the features on the MView platform. The admin panel on the left-hand side of your screen is where users can be added and deleted. Only local admins have access to this tab though. The logout button located in the bottom left-hand corner of the interactive map should be used every time you are finished using the MView platform so no one can use your account but you. Tab 9 is the links. Although PennDOT currently does not have any links available, things like public transit for bus and rail maps can be put here, bike routes, and park and ride routes can be put here. This will be used just like the Links tab on the 511 PA website. Tab 10 is the Filters tab. This will allow you to filter down the cameras that you want to see on the map in a particular region and eliminate any of the other cameras that are not in this region. Tab 11 is the Shortcuts tab. Very similar to the Filter tab, this will allow you to zone in on a region of cameras that you would wish to view and use most frequently. Here, you are able to customize your personal Shortcuts tab, where you can add regions that you view often. Tab 12 is the Layers tab. Here, you are able to click on the layers you want to use on your map. You can choose from a weather layer, a buildings camera layer, a traffic cameras layer, and an incidents layer. Similar to the Incidents tab on the left-hand side of the page, the Incidents tab on the top of the page will do the same thing and populate the incidents on the right-hand side of your screen in a list form. In this list form, you can click on an incident and it will again populate the 4 closest cameras to that incident along with any information to the incident. Tab 14 is a search bar. Here you can simply search for a camera by its name and it will pull you right to that camera on the map. Tab 15 will allow you to either expand or minimize the cameras that you originally selected on the interactive map. It also gives you the option to push it to your video wall where you could select more cameras to view, or by clicking the X you will simply close out all the streams that you selected and the streams will now be blank. Once you click the exit button, you will be able to select 4 new cameras to view on the bottom of your screen, and if you wish, you can then push them to the video wall just like before. Next, we will look at the 2 types of MView users. First is the PennDOT users. They include district executive leadership and incident commanders, county managers and assistant county managers that are not connected to the PennDOT network, and county radio operators not connected to the PennDOT network. Next, the non-PennDOT users. They are government agencies, first responders, public safety personnel within Pennsylvania, and management centers, such as 911 centers, dispatch centers, and watch centers. If a PennDOT employee wants to gain access to the MView platform, they simply have to send an email to mviewadmin@pa.gov. This is a resource account created by PennDOT for MView. A key points page and a user request access form will be provided to the applicant. Both of these forms are required by MView. The key points page should be initialed and dated on the line in the top right corner of the page. The user request access form should be filled out by the applicant. Instructions on certain sections will be provided. Once the forms are received back through the resource account, they will be sent to MView for review and approval. Once granted approval, the MView resource account will send a confirmation email to the applicant with their username and password. The user can then test their login information at the link provided below. If there are any issues logging into the MView website, the user can email the resource account with any problems. Finally, we will talk about the business partner access process. First, the applicant must email mviewadmin@pa.gov. This is a resource account for PennDOT. The applicant must then first fill out the PennDOT non-exclusive video sharing agreement. Next, a key points page and a user request access form will be provided to the applicant, both of which are required by MView. The key points page should be initialed and dated on the top line in the top right corner of the page. The user access request form should be filled out by the applicant. Instructions on certain sections will be provided, including an example form. Forms will be sent back to MView for review and approval. Once granted approval by MView, the MView admin account will send a confirmation email to the applicant with their username and password. At this point, they can go to the link below and test their login information. If there are any problems, they can feel free to email mviewadmin@pa.gov.
Hello, welcome to the Virtual Innovation Days presentation on APRAS modernization. This will be a project overview walking through the goals, objectives, current state, and some of the innovative, not only technical practices, but also project innovations throughout the APRAS modernization project. My name is Ben Huffnagel. I'm the Senior Project Manager on the APRAS modernization project. Starting off some background on the APRAS system. The Automated Permit Routing and Analysis System is PennDOT's system for the permitting of oversized overweight loads and issues over 400,000 permits per year. While the automated system was first launched in 1998 and was state-of-the-art, much like all of us 20 years later, starting to show its age. One of the key drawbacks to the legacy system was that when specifying a route, users needed to use a series of text-based prompts to show all of the roads they were going, rather than what many of us in today's day and age expect of being able to use a map, something akin to Google Maps or the like. So the need for modernization of APRAS being identified, the following objectives were laid out. Overall, the goal is to implement a custom solution, something just for PennDOT, that's going to be superior to any available commercial products. Being a new software solution, this of course needs to reflect PennDOT's security and architectural technology standards, and also incorporate mapping and GIS functionality, specifically in routing selection. Also, the Federal Highway Administration has created best practices for oversized overweight vehicle permitting. We want to make sure that these are incorporated into the application, things like automated route creation and checking of clearances. Giving the external business partners a better user experience. Now that web apps are used throughout life, we want to make sure this is something that lines up with expectations. And additionally, want to eliminate time that's involved in the manual creation and the manual review of these routes to make it easier, faster, more efficient to request and have a permit issued. Giving a quick overview of the timeline of the project, project started back in the summer of 2018, and by the end of 2019, the modernized external site had been released to production. This is a site that carriers and permit services used when they submit their applications. Just recently, we had a big milestone of shifting the infrastructure out to the cloud. This is one of the first handful of applications within PennDOT that will be hosted out in Microsoft's Azure infrastructure. The project will keep going with the final modernization go live set to complete in Q1 of 2024. So as mentioned, we are in the middle of the project, so I do want to highlight some of the accomplishments that we have to date. First and foremost, the release of the external site back in 2019 was extremely successful. And one of the reasons believed for this was the phased rollout that we did. On the first day of go live, there was actually only a single carrier, High Transit, down in Lancaster that began using the system. This was done to reduce the risk and prioritize the continuity of the business. This is a very mission critical system, so we want to make sure we did whatever we could to minimize this risk. As we brought on more users, more carriers, actually throughout COVID, ending in about mid-2020, we were able to adapt our onboarding processes, see the load of the system slowly increase, so we were able to verify that it lined up with the performance testing that we did. Help us to adapt some of our documentation just to make sure it was as smooth as possible. To date, there have been over 476,000 permits issued to date by the system. So this is something that we have seen plenty of usage and every combination of load and road that you can see. And really going to the cloud migration, I want to highlight here that we are now on highly reliable, highly scalable hosting so that as system usage goes up, we can increase the resources that we have available to make sure this is something that grows as the system grows and stays as performant as possible. And additionally, this was done at reduced cost from the previous infrastructure, so not only able to get increased performance, but for less money. So 6 slides in, when talking about a modernized web application, I'll actually show the modernized web application. What we really want to highlight here, as we're showing it, this is the landing page, the dashboard that users see when they enter APRAS. Want to make it as clean as possible, yet presenting as much, useful information to the users as they come in. Want to incorporate urgent alerts as the users come in. This would be things such as road closures, really the system's going to be down, or, oh, by the way, there's been a landslide, please be aware. Things that would affect not only the users as they use the system, but also as they start planning the routes. Getting into the route planning as well, one of the key features that we have is the route restrictions map. Being able to scroll in, zoom in, search for road closures, construction, things of the like that would be affecting the planning that they have coming up, to make sure that when they are doing their route planning, they have as much information available as possible. And then for system navigation, being able to show them, here's your recently issued permits, here's the applications you submitted, what the status is, being able to dive into all of this very quickly and very smoothly. The key innovation, the key feature of the modernized APRAS, at least the external web app, though, is the map-based routing, and we'll touch on that here. So as mentioned in the previous system, it was you had to select the intersection you started out from a drop-down, and in a series of drop-downs in a wizard, do text-based, leg by leg, how you get to your route. Had to do all of your planning outside of the system and go in and sometimes just hope. What we have now is something more akin to what all people expect at this point. Put in a point that you start at, put in a point that you end at. What's a route that we're going to suggest? This is something that the system will suggest a traversable and efficient route, but the user isn't forced to take this. They're able to shape the route by dropping waypoints if they need to specify a specific route due to preference, due to that's where they surveyed the route, or just for whatever reason, they're able to do that route, and the system will work with them to get that route. And one of the key features here, one of the things that distinguishes this from, say, a Google Maps or something that routes non-commercial vehicles, is this avoids clearance issues. And that's dependent on the dimensions of the vehicle that you have specified. If you are driving a 15-foot truck, 15-foot high truck, it's not going to route you under a 12-foot bridge. In fact, even if you try to shape a route to go through a 12-foot bridge, the system will either route you around it or say you can't get a route here. It will not allow a route to be submitted that will hit an obvious clearance violation. And this also goes into construction, restrictions, road closures. If there are Jersey barriers set up and it's a restrict to 11 feet wide, I can get through in my Honda Civic, but if I'm trying to move a mobile home that's 20 feet wide, the system's going to route me around it. In addition, as I mentioned, the other thing that we do pull in here are the vertical bridge clearances when they're routing. So what this does is it helps enable a user, as they're making their route, to more reliably get a route that will get accepted. Cut out things that the users would be manually putting in that they might not be aware of restrictions or aware of a bridge. Make sure this is something that makes it as safe as possible. So with the completion of the front-end carrier web application, we have shifted some of the back-end modernization, not only the analyses process, but also the system that's used by PennDOT users. One of the key things here are the bridge analysis and roadway analysis. This is the more in-depth analysis of a submitted route that makes sure that it is truly safe, and not only for the citizens, but also the infrastructure. These are obviously safety critical, and so one of the things that we're doing is when we have these complete, we will be running them side by side with the existing analysis systems. To anything that goes into the in-production system will go into our system as well, so we can compare those results, make sure that we are either getting the exact same results or we have improved upon them. And also we are looking at the manual review process, something where we are looking to see where we can streamline this, where we can improve the auto issuance rate, where we can find things that right now the system makes a user look at it, but nobody ever actually dives into it because they 100% of the time accept that or 100% of the time reject that. Don't have users burn time in looking at some of these things, have them more focused on mission critical, safety critical items that might come up. So as well as the technical innovations, I do want to highlight some of the project approach innovations that we have in this modernization project. First, in general, this is a modernization of an existing system. And so we are being able to completely modernize all existing code base, infrastructure, makes us much more maintainable. But because we are doing this piece by piece, one of the things we're doing is making sure that the modernized system works alongside the legacy system. Right now, applications are submitted through the modernized system, but actually reviewed and issued outside of the legacy system. They work in concert. And as I mentioned with the manual review process, we're not only modernizing the system, we're modernizing the process. So as we go through each of these, we really want to see what process innovations can we present with new technology? What limitations did the old system ingrain into the business process that are no longer needed? Where can we remove some of those roadblocks and open up new avenues for process innovations by using new technology? One of the biggest things that I want to highlight, and one of the most innovative approaches I'll say we had here, is the involvement of end users and stakeholders throughout the entire process. This is something that has been a focus of the team and I think will be paramount to our success. Throughout the life of the project, we have had meetings, site visits with the carriers, a few of them locally, a few of them virtually, wanting to make sure that this is a system that is used by carriers. Let's talk to carriers. Let's talk to permit services. See, how do you use the system? Where does it fall down? Where does it do things really well? What do we want to improve? What do we want to leave in place? Kind of had that throughout. Additionally, we've met with users in all 11 districts and the central office to see, how do you use the system? How is it different from other users? What do you always have to have near you that may be more beneficial to have on screen? And so as we developed these things, we then had targeted feedback sessions to be able to say, hey, we heard what you said. This is what we pulled apart. Did we get it right? Did we get it wrong? How do we need to change that? And being able to kind of incorporate that as we go forward. Additionally, as we got ready to go live, we had training sessions to make sure that the users were ready to use the system. And then something that I think is probably neatest about all of this is we had a hands-on rollout. The first carriers, when they put in the first permit into the new APRAS system, they had members of the APRAS modernization team literally right beside them in their office. We did it for the first 3 users just to make sure if anything went wrong, which thankfully it didn't, we were there to be able to assist them and walk them through these things. And finally, the aspect of the approach that I want to highlight, I've touched on a little bit, but I want to, shine a light on it here, is the iterative development that we're doing, and 2 key aspects there. The first, as I mentioned before, is that iterative feedback. We don't want to ask what you need done, see in 9 months, this is what we did, we're out. We want to have as many short feedback opportunities to be able to say, hey, we went off for a couple of weeks. This is what we made. Did we nail it? Hey, we've been going for a couple of months, but how's this work? And also making sure that feedback informs the next steps. I don't want the team to say, oh, you don't like that? Cool, we're going on with it anyway. We want to make sure that we are saying, I heard you. This is how we've changed it going forward. And also iterative delivery. When functionality can be released, it is released. As mentioned before, the modernized external web app is running in production today. We're not done with the project, but there was value to be had by delivering that. I wanted to make sure we were delivering that value incrementally. We won't want to hold everything until the end just because. When we can put things forward, let's do that to make sure that we're delivering and driving value as much as possible throughout the lifetime of the project. So as mentioned, I am Ben Huffnagel, the project manager on the APRAS modernization project. I want to thank you all so much for your time today, and I'm excited to continue on with the modernization of APRAS as we keep going through the lifetime of the project. Thank you so much.